Welcome back, everyone. So in this video, we're going to talk about solving exponential and logarithmic inequalities. So prior, we talked about solving all these different equations like we did before. So this is going to be a continuation from the previous video. So starting off, we're going to let f of x equals natural log of x plus 10 minus natural log of x, and then g of x is going to equal natural log of x plus 3. You want to find all values of x where the graphs of f and g are going to intersect. So if I'm saying the graphs are just going to intersect, then what you're going to do is you're going to take f of x and g of x and you're going to set them equal. So I'm going to have a setup of f of x equals g of x, and then I'm going to sub in. So we're going to have natural log of x plus 10 minus natural log of x, and then that's going to equal g of x, which in this case is going to be natural log of x plus 3. So what's going to happen is we want to condense on both sides. So on the left side over here, natural log of x plus 10 minus natural log of x, because I'm subtracting, I'm going to rewrite this as a single log where we're dividing. So we're going to have natural log of x plus 10 divided by x, and that's going to equal the natural log of x plus 3. And then what's going to happen is we're going to put that in parentheses. Now that our logs have the same base, I'm going to set my arguments equal. So I'm going to have x plus 10 divided by x, and that's going to equal x plus 3. So in order to solve this, I'm going to multiply both sides by x. Now on the right side, when I multiply, I'm going to put the x plus 3 in parentheses. So we're going to have x plus 10 equals x parentheses x plus 3, so I'm going to go ahead and distribute, and that's going to give us x squared plus 3x. So I'm going to rewrite. So we have x plus 10 equals x squared plus 3x. So now I want to move everything from the left side to the right side because I want to keep my x squared value. I'm going to keep it positive. So if the x squared here was negative, then I would move everything from the right to the left. So in this case, I'm going to move the left side to the right side. So I'm going to subtract x and then subtract 10. So doing this is going to give us x squared plus 2x minus 10 equals 0. Now I want to solve this quadratic so that we can find the x values where these two logarithmic equations are going to intersect. So first thing you want to check is if it's factorable. Unfortunately, this one's not factorable, so that means we're going to have to do quadratic formula. So as a recap, your quadratic formula, which you will be expected to know off the top of your head. So x is equal to plus or minus square root of b squared minus 4ac all over 2a. So when I plug in, so I'm going to have x is equal to the opposite of b, which is going to be negative 2, plus or minus the square root of my b value squared, which is going to be 2 squared, minus 4 times my a value, which is 1, times my c value, which is negative 10. And that's going to be all over 2 times my a value, which is 1. And we're just going to simplify this hot mess. So when you get here, so negative 2 plus or minus square root. So this is going to be 4 plus 40 all over 2. So this is going to give me negative 2 plus or minus the square root of 44. And then you're going to want to simplify the square root of 44. So this should hopefully be a review. So when I do the prime factorization of 44, we're going to look for pairs. So I know 44 is divisible by 4 and 11. And then 4 can be divided by, or multiplied by 2 and 2 to get 4. And then when you get here, what you're going to look for are pairs. So I have a pair of 2's and then I have a singular 11. So as a recap, once that number factors into 2 other values, then that number is done. So when I have a pair, that number is going to be written on the outside just one time, and then anything that didn't pair off is going to be on the inside of the radical. So the square root of 44 is going to be the same as 2 root 11. So over here, I'm going to rewrite. So negative 2 plus or minus 2 root 11, and that's going to be all over 2. And then I want to simplify even more. So I'm going to split and give each numerator its own denominator. So I'm going to rewrite as 2 over 2 plus or minus 2 root 11 over 2. So when I simplify, this is going to give me -1 plus or minus the square root of 11. So these are going to be the potential values that we have of x where these graphs are going to cross. However, what you've got to remember is that we're dealing with logarithms. And ask yourself, what types of values can I not have in a logarithm? You cannot have negatives. So if I go over here, I see that this is going to split into two different x values. So the first value I would have would be x is -1 minus the square root of 11. And then I also have x is -1 plus the square root of 11. So the square root of 11 is going to be between So it's going to be 3 point something squared, essentially. So if I were to do -1 minus 3 point something, that's going to give me a negative, which means this value here would be extraneous. So we would completely disregard that top solution. But if I have -1 plus 3 point something, that's going to be a positive value, which means this is the only value that we want. So the graphs of f of x and g of x are going to intersect at an x value of -1 plus root 11. Okay, now looking over at the next one. So now we want to let h of x equals log base 3 of 2x minus 3 plus log base 3 of x plus 4. And k of x is going to be log base 3 of 8x plus 2. In the xy plane, what are all the x coordinates where they're going to intersect? So same idea here. We're going to set these two equations equal to each other. So anytime you see where it's asking for a point of intersection, that's going to be an indicator to you that we're going to set these equations equal. So I want h of x to equal k of x. So when I write in, so I'm going to write in log base 3 of 2x minus 3, and then plus log base 3 of x plus 4, and then that's going to equal k of x, which in this case is log base 3 of 8x plus 2. So when you get here, so on the left side, I need to condense this into a single log before I can set the arguments equal. So because I'm adding, I'm going to multiply the argument values. So I'm going to have log base 3 of 2x minus 3 times x plus 4, and then set that equal to log base 3 of 8x plus 2. So now that I have a condensed logarithm on both sides, we have log base 3, log base 3. Now I'm going to set the arguments equal. So I'm going to have 2x minus 3 times x plus 4, and then that's going to equal 8x plus 2. So over on the, or I'm going to come over here and I'm going to expand. So when I expand, so that's going to give us, so 2x squared plus 8x minus 3x minus 12. And then that's going to equal the right side, which is still 8x plus 2. And then I'm going to condense, or combine like terms rather. So 2x squared plus 5x minus 12, and that's going to equal 8x plus 2. And then we're going to move the right side over to the left side. So I'm going to subtract 8x on both sides. So we're going to have 2x squared minus 3x, and then subtract 2 on both sides, then minus 14 equals 0. So what you want to do next is we're going to try and factor this equation if possible. So I'm going to look at factors of 2 times negative 14. So I want factors of negative 28 that are going to add up to negative 3. So we have 1 and 28, we have 2 and 14, and we also have 4 and 7. So I can get 4 and 7 to add up to negative 3 by making it a negative 7 and positive 4. So this equation is factorable. So what I'm going to do is move this over, and then I'm going to rewrite. So I'm going to have 2x squared minus 3x minus 14. So when I factor, we're going to have 2x squared, and then the order doesn't matter, so I'll do plus 4x first, and then I'll subtract 7x, and then minus 14, and then you're going to do grouping. So in the first two terms, I can take out a 2x, So when I take out a 2x, that leaves me with x plus 2. And then in the second group over here, negative 7x minus 14, I can factor out a negative 7. And that would leave me with x plus 2. So then when I rewrite in factored form, this would be x plus 2 times 2x minus 7. And then that would equal 0. So when I set both of these values equal to 0, so we would have x values of negative 2 and positive 7/2. But once again, we're dealing with logarithmic equations. So I need to take my solutions and I'm going to plug it in to all my log values. And I want to make sure that we get positive values. So if I plug in negative 2 into the first log over here, so 2 times negative 2 minus 3, that's going to give me negative 7. So I get a negative value in the argument here, which means automatically negative 2 is extraneous. So this doesn't work. So if I plug in 7/2, that's 3.5. So 3.5 times 2 minus 3, that's going to be positive. It works. 3.5 plus 4, positive. It works. 3.5 times 8 plus 2, that's going to be positive. So it works. So the only solution that we're going to have here is going to be the singular value of 7/2. Okay, and then now we're going to look at a logarithmic inequality. So I'm going to try to start off at kind of a level 1 problem. Although with logarithmic inequalities, there's not a lot of level 1 to go around. So I wrote out the 3 big steps for you. So the first step is you're going to find restrictions of f of x. You're going to set each factor to 0 and solve, because in logarithms, you can't have any negative values in your argument. And then for step 2, you're going to find any points of intersection. So you're going to actually do what we just did. Like this entire problem up here is actually step 2 in these problems. And then step 3 is you're going to make a sign chart. So start off, we have f of x equals log of x squared minus 4x plus 7 minus log of x plus 3. And we want to find the values of x for which f of x is greater than 0. So this is a very fancy, complicated way of saying I want to know where is it positive. So to start off, I want to find all the restrictions. So I'm actually going to try and separate this into other parts. So find restrictions means I'm going to take each of my individual arguments and I want to set them greater than 0. So if I have x squared minus 4x plus 7, I want to set that greater than 0, but then I also want x plus 3 greater than 0. So what's going to happen is I need to either factor or do quadratic formula to figure out how the quadratic over here is going to simplify. That way I can figure out what restrictions I have. So what's going to happen is this quadratic is not factorable, so I need to do quadratic formula. But to make things a little bit quicker for you, I would actually recommend just finding the discriminant. So the discriminant is going to tell you how many solutions you have, which will kind of cut down the quadratic formula usage in half, I would say. So as a quick recap, your discriminant is just b squared minus 4ac. It's just the part that's in the radical of quadratic formula. So if it's greater than 0, that means we're going to have 2 solutions. If it's equal to 1, we only have 1 solution. And then if it is negative, if it's less than 0, then we have no real solution. We'd have 0 solutions. So this is what I'm checking. So when I plug in, so b squared, which would be negative 4 squared, minus 4 times my a value times my c value, which is 7. So this would be positive 16 minus 28, which that's going to give me negative 12. So because your discriminant is negative, that means this component has no real solutions. So what that tells me is just this one part, we're not going to have any restrictions on just this little part, which means my restrictions are going to be dictated by just this other inequality over here, which thankfully is a one-step equation. So over here, x plus 3 greater than 0, of course, just subtract 3 on both sides. So this tells me my restriction here is all my values have to be bigger than negative 3. If they're not bigger than 3, then it won't work. Okay, so now for step 2, now we're going to solve for any points of intersection. So I have log of x squared minus 4x plus 7, and then minus log of x plus 3. And I want this to be equal to 0. So let me rephrase this. So when I say points of intersection, this is if we have multiple logs. But if we have a singular log, then this step is really just find the roots of the log. This is if it's single, just a single logarithmic equation. So finding intersection is if you have two log equations. So let me add on to that part. So since we're just dealing with a single logarithm, we're just going to find the roots. So with this equation, I'm going to add log of x plus 3 on both sides. So I'm going to have log of x squared minus 4x plus 7. That's going to be equal to log of x plus 3. So now that the values are the same, then I can set them equal. So we're going to have x squared minus 4x plus 7 equals to x plus 3. And then I want to subtract on both sides. So I want to move the values on the right side to the values on the left. So I'm going to subtract x, and then subtract 3, and subtract 3. So doing this, we're going to get x squared minus 5x plus 4 equals 0. So when we get here, then once again, I want to see if this is factorable. Otherwise, we'll have to do quadratic formula again. So factors of positive 4 that add up to -5. This is factorable, thankfully. So this would be x minus 1 and x minus 4. So this is going to give us values when we solve of 1 and 4. So now what's going to happen, now that we have our restrictions in step 1 and we have any roots or points of intersection on step 2, now I'm going to make a sign chart with my values from step 1 and step 2. So what I'm going to do is, first off, I want to be able to count to see how many values I need to account for. So if we have any values over here, you're going to want to account for those. Of course, any values over here, and then any values where you intersect. So these are going to tell you all the values that you need on your sign chart. So in this case, I need 1, 2, 3 values on my sign chart. So when I make my sign chart, make it spacious enough, but not too spacious. And then, of course, since we're dealing with the sign chart, you need to put your values in order, numerical order. So -3 is going to be the first value. And then we're going to have 1 and 4, which are where we have roots. Okay, and then based on my restrictions over here, I have to be bigger than -3. So what that tells me is anything to the left of -3 here, it does not exist. So that would be my restriction. So once I have that restriction in place on my sign chart, now I'm going to look for test values. So a value in between -3 and 1, I'm going to test 0, my favorite number. And then 1 to 4, I'm going to test 2. And then between 4 to infinity, you have literally an infinite number of choices. I'm going to test 5. I always choose the values that are closest to 0. Now with your test values, what's going to happen is you're going to plug these in to the original. And you're going to check to see whether the sign is going to be positive or negative. Okay, so if I plug in 0, I want to plug in 0 into my original equation up here. And I want to see, is the result going to give me a positive value or a negative value? So when I write, so I'm going to test f of 0. So if I were to test f of 0, then if I plug in 0, this is going to give me 0 minus 0 plus 7. And then over here, that'd be 0 plus 3, which would give me log of 3. So over here, this is going to give me log of 7 minus log of 3. Now, keep in mind, we don't need to know the exact value. I just need to know if it's going to be positive or negative. So log base 7 minus log base 3, that's going to give me a positive number. So what that tells me is on this interval, we're positive. Now I want to test f of 2. So when I test 2, So this would be 2 squared, which is 4, minus 4 times 2, which is 8, plus 7. So 4 minus 8, which is negative 4, plus 7 is going to give me 3. So this would be log of 3. And then for the next one, so if I plug in 2, that's going to be log of 5. So minus log of 5. Now I have log of 3 minus log of 5. That's going to give me a negative value. So what I try to tell people is try to ignore the logs and just look at the values. 7 minus 3 is going to be positive. 3 minus 5 is going to be negative. So try to use that logic when you're looking to see when a value is positive or negative. Okay, and then last but not least, now we also have f of 5. So when I plug in 5, so 5 squared is 25, minus 20, which is going to be 5, plus 7, which is going to be log of 12. And then minus log of 8. So 12 minus 8 is going to give me a positive number. So this would be negative, this would be positive. So I specifically want the interval where f of x is going to be positive. So my final answer here would be from negative 3 to 1, and then union 4 to infinity. So we do not want to be equal to anything yet. So the only thing that you could be equal to would, in this case, would be the x-intercepts. So if this was changed to greater than or equal to, then I could put brackets on those values. Okay, next, now we're going to let g of x equals natural log of x squared plus x minus 5, and h of x equals natural log of x plus 4. We want to find the values of x, which g of x is less than h of x. So for this one, I'm not going to lie, this one's going to be kind of a lot. I will say majority of these, you should be able to do these without a calculator, but I will say for this problem in particular, go ahead and grab that calculator. So starting off, I have g of x and h of x. I want to find my restrictions first. So I'm going to focus on just the argument values. So I want x squared plus x minus 5 to be greater than 0, but then I also want to do x plus 4 greater than 0. Okay, so what's going to happen, I'm going to go ahead and do the booger first. So let's go ahead and do the discriminant to see if it's even going to be factorable, or if it even crosses the x-axis. So I'm going to do b squared minus 4ac. So b squared, which would be 1 squared minus 4 times my a value times my c value, which is negative 5. So that's going to be 1 plus 20, which means that we're going to have 21 as our discriminant, which means it's going to cross the x-axis twice. So when I do quadratic formula, so I already did the discriminant. So I'm going to do the opposite of b, so negative 1 plus or minus the square root of the discriminant, which is 21, all over 2 times my a value, which is just 2. Now, when you get here, these restrictions here, I'm going to make a tiny little sign chart with just these values. So I'm going to have a value where it's negative 1 minus the square root of 21 over 2, and then negative 1 plus the square root of 21 over 2. So what's going to happen is in a logarithmic equation, when it's squared, typically your log is going to go up and over something like this. But when you square it, we can also account for the negative values because they're squared, so they're also going to become positive. So now you're going to have what looks like some antennae from an insect. That's what it kind of looks like. You're going to have that on going out on both sides when you have a squared function like this. But the distinction that you're going to have to be careful about is you may have a portion over here going left and then a portion over here going to the right, but you need to figure out what these vertical asymptotes right here are going to be. And that's what these numbers are. So what this tells me is I can't be anything in between. So inside, this would be a does not exist. But on either side, these values would work. So I'm going to need this little setup for when I do my sign chart in step 3. So I'm going to shrink this a bit. Okay, I guess not. There we go. Okay, and then over here on the next step, so x plus 4 greater than 0. I know, this one's the travesty. So x has to be greater than -4. All right, so next part is we want to look for where they're going to cross. So I'm going to look for points of intersection. So points of intersection tell me I'm going to take g of x and h of x, and I want to set them equal to each other. So to start off, I'm going to have g of x equals h of x, and then I'm going to do natural log of x squared plus x minus 5, and that's going to equal the natural log of x plus 4. So we already have the same log base on both sides, so I'm just going to go ahead and set my arguments equal to each other. So my arguments, we're going to have x squared plus x minus 5 equals x plus 4. I'm going to subtract x on both sides and then subtract 4 on both sides. So we're going to have x squared minus 9 equals 0. And then when you solve, we're going to get an x squared value of positive 9, which means we're going to have x values of plus or minus 3. So what that tells me is I'm going to have 1, 2, 3, 4, 5. I'm going to have 5 values on my sign chart. So remember, I count 3 over here twice because we have to account for positive 3 and negative 3. So once again, 1, 2, 3, 4, 5. So when I make my sign chart, there we go. I'm going to make my sign chart spacious enough where I can have 5 values and I can write in it and on it. So I'm going to do 1, 2, 3, 4, 5. Close enough. So once again, you need to put these values in numerical order. So what's going to happen is you're going to have to be able to evaluate some of these numbers mentally. Now, when you get ugly numbers like this, I personally don't want to make you do these by hand because I don't want you to get counted off for just not knowing off the top of your head what this is. So I would say you can use these or use your calculator on those steps only just to approximate those numbers. So over here in order, I'm going to go ahead and write them out. So we're going to have -4, and then the next value would be -3. Then your next value would be -1 minus the square root of 21 over 2. And then your next value, we're going to have -1 plus the square root of 21 over 2. And then we're going to have positive 3. Now, once you create your sign chart, then you're going to want to go back to your restrictions and list and label where we cannot be. So I have to be greater than -4. So over here, this value here would be does not exist. We're not going to have anything in that interval. And then another interval is going to be in between the radical values over here. So in between over here, this would also be a value that we are not going to have to test. There we go. All right, so when I plug those values in, these radical values, this is going to give me about -2.5-ish. And then when you add, this is going to give you about 1.5-ish. So I was approximating these mentally, kind of, so they may be off a little bit, but they're pretty close. So once I established my restrictions and I got my sign chart put together, roughly, now I'm going to find some test values. So over here, between -4 and -3, well, this isn't going to be pretty. I'm going to test -3.5. So anytime I have decimal values that I need to test, I'm just going to grab my calculator. Okay, and then over here, between -3 and -2.5, I'm not 100% certain what that value is, so I want to be closer to -3. So for here, I'm going to test -2.9, just to be on the safe side. Okay, and then in between, we don't have anything here, so we're not going to have a test value. So between 1.5 and 3, I'm going to test 2. And then on the other side, I'm going to test 4. So we have 3 values that we need to test. All right, so I'm going to start over here with these gross ones. So let's start off with just the inequality itself. So this is the inequality that we want to establish and solve. So I want g of x less than h of x. So what's going to happen is I'm going to rewrite this. So I'm going to rewrite it as g of x minus h of x is less than 0. So what I'm going to do is I'm going to plug in my test values into both of these equations, and I want the result to be negative in order for it to work. So based on this setup, we want negatives. Okay, so now I'm going to go ahead and start doing my test values. So I want to do g of negative 3.5 minus h of negative 3.5. So when I plug in, for the decimal values, not going to lie, I use my calculator. This is going to give you a positive value. So I'm just checking the sign. I'm not checking the value, I'm just checking the sign. Okay, and then I'm going to plug in negative 2.9. So g of negative 2.9 minus h of negative 2.9. So once again, on my calculator, I'm going to plug that in, and that's going to give me a negative number. So I know up here, that would be negative. Okay, and then the next interval, or the next test values, is going to be 2 and 4. So these I can do by hand since they're pretty numbers. So I want g of 2 minus h of 2. So when I plug in, so g of 2, so that'd be 4 plus 2 minus 5, so 6 minus 5, which would be 1. So this is going to be natural log of 1, and then I want to do h of 2. And I'm going to subtract that value. So h of 2 would be natural log of 2 plus 4, which would be natural log of 6. Oops. Minus natural log of 6. So when I look at my values, 1 minus 6, that's going to give me a negative value, which is what we want. So I'm going to put that negative up here. And then I'm going to test 4. So I want g of 4 minus h of 4. So when I do g of 4, so that's going to be 4 squared, so 16 plus 4 minus 5, so 20 minus 5, so that's going to be natural log of 15. So natural log of 15, and then minus h of 4. So 4 and 4 is going to be natural log of 8. So minus natural log of 8. So 15 minus 8 is going to give us a positive number. So over here, this would be positive. So reference over here the fact that we want negative values. So we're looking specifically where on our sign chart do we have negative values. So I want from here to here and then from here to here. So in this case, my answer would be negative 3, comma, whoops, parentheses, losing my mind over here. So negative 3, comma, going from negative 1 minus root 21 over 2, union, and then negative 1 plus square root 21 over 2, going until 3. So this would be the interval that we want. So this is a good problem. Okay, 35. This is kind of a breath of fresh air to kind of take a quick little break from logarithmic inequalities, because the exponential inequalities are not nearly as bad. So we're going to let k of x equals 1 minus 4 times 2 raised to the x minus 3, and we want to find the values of x where where k of x is less than or equal to negative 31. Now pay particularly close attention to the fact that we want it to be less than or equal to. So in this case, we could use brackets. So I'm going to treat it like an equation. So I'm going to set k of x, and I want it to be less than or equal to negative 31. So when I sub in my equation, 1 minus 4 times 2 raised to the x minus 3, less than or equal to negative 31. Now I'm going to solve it just like I would a normal equation. So subtract 1, subtract 1. So we're going to have negative 4 parentheses 2 raised to the x minus 3. That'd be less than or equal to negative 32. Then my next step is I want to get rid of that negative 4. So we're going to have 2 raised to the x minus 3, and then negative 32 divided by negative 4 is going to give me a positive 8. Now, what you've got to remember, when I divide by a negative, think back to your middle school Algebra 1 days, what happens to my inequality sign when I divide by a negative? It's going to flip. Now, if I divided by a positive, then it would stay the same. But all because I'm dividing by that negative, it's going to flip. So when you get here, now it's just a matter of solving. So I'm going to rewrite 8 with the base of 2. So 2 raised to the x minus 3 greater than or equal to 2 raised to the third power. So when I get here, then I'm going to set my exponents equal, or rather, I'm just going to take the inequality. So that would be x minus 3, and I'm going to keep the inequality sign greater than or equal to 3. And then solve it, so I add 3 on both sides, so x is greater than or equal to 6. So notice how I can be equal to it, and I want everything bigger than 6. So this would be 6 with the bracket going to infinity. That would be your interval. All right, so let's move on. So 36, you're going to let f of x equals log base 2 of x squared plus 5x minus 13 minus log base 2 of 3x minus 5. We want to find all values of x where f of x is less than 0. So once again, I want everything less than 0, which means I'm looking for where are my values negative. Okay, so go ahead and whip out that calculator. You're going to want to use it on this problem. I tried to come up with problems that didn't require a calculator, but unfortunately it can be difficult coming up with some good problems like these without a calculator. So first thing is we're going to do restrictions. So I'm going to take x squared plus 5x minus 13 and 3x minus 5, and I'm going to do my restrictions. So I'm going to have x squared plus 5x, where is my value? There it is, minus 13, set equal to 0, but I've also got 3x minus 5 equal to 0. Or not equal to 0, sorry. We want greater than 0 because our values have to be positive. Otherwise, the value doesn't exist in the log. All right, so what's going to happen is I want to try and factor the left side. Unfortunately, factors of 13 are just 1 and 13. No way they can add up to 5, which tells me I have to do quadratic formula. But I do want to check the discriminant to see how many solutions we're going to have. So when I check, so we're going to have b squared minus 4ac. So that's going to be 25 minus 4ac. So that's going to be 25 plus 13 times 4, which is going to be 52, which that's going to give me 77. Oh, goody. All right, so now when I do quadratic formula, so that's positive, so this tells us that we're going to have 2 x-intercepts. So I need to find said x-intercepts. So the opposite of b, so negative 5 plus or minus the discriminant value, or square root of the discriminant value, all over 2 times my a value, which is 1. So in this case, same idea as before, we're going to have a little mini sign chart within our problem. So I'm going to have negative 5 minus the square root of 77 over 2. And then we want negative 5 plus the square root of 77 divided by 2. So just like before, your log is going to go up to the left on one side, and then it's going to go up to the right on the other side. So what's going to happen is we can't be anything in between. So in between these is going to be does not exist. But we do have points to the left and to the right of those values. So now I'm going to do my restriction on the other one. So we have 3x minus 5 greater than 0. So that's going to be x is greater than 5/3. Okay, so now we have 3 points so far for my sign chart. So now I need to find where we're dealing with a single log, so I need to find where we're going to have roots. So I'm going to take my equation and set it equal to 0. So log base 2 of x squared plus 5x minus 13 minus log base 2 of 3x minus 5, and I'm going to set that equal to 0. So I'm going to move the log base 2 of 3x minus 5, I'm going to move it to the right side. So we're going to have log base 2 of x squared plus 5x minus 13 And I'm going to set that equal to log base 2 of 3x minus 5. So now that we have the same log base on both sides, now I'm going to set the arguments equal. So x squared plus 5x minus 13 is going to equal 3x minus 5. Now my x squared value over here on the left side, it's positive, so I want to keep it where it is, which that tells me I want to move everything from the right side to the left. So when I subtract 3x on both sides, and then I'm going to add 5. So that's going to leave me with x squared plus 2x minus 8. And that's going to equal 0. Now, thankfully, this quadratic here is factorable. So this would factor to x plus 4 and x minus 2, which means we're going to have values of -4 and +2. So when I look at my restrictions and points of intersection, or not points of intersection, but my roots rather, so I have 1, 2, 3, 4, 5. So I need 5 values for my sign chart. So anytime you have like 4 or more values, that's where it's going to get kind of dicey. So I want 5 points. So 1, 2, 3, 4, 5. I'm about to get kicked out of the library.
The library will be closing in 30 minutes.
Thank you.
Library card registration and acceptance of payments will end in 10 minutes. Please complete all payments and library card requests at this time.
Thank you. All right, so I need to put these values in numerical order. So, of course, like I would say, plug these on our calculator, get the actual value. But my order, I'm going to go ahead and jump a couple steps. So this is going to be -5 minus square root of 77 all over 2. It's going to be the first value. And then 5/3 will be your next value. And then we have -5 plus the square root of 77 over 2. Can I not count? Oh, I can't count because my bad, y'all. Over here, whoopsie doozy. If I plug in -4 here, we get a negative, so it's extraneous. Might be. I knew something looked weird. So -4 here, this is extraneous. I forgot to do my own rule. So when it's extraneous, you just disregard. Might be. Okay, so we actually only have 5 values, or 4 values on the sign chart. So based on the context of our restrictions, I cannot be in between these 2 radical values. So anything in between, so all these 2, or all these intervals right here, are going to be D and E. Which, thankfully... Okay, and then my other restriction is going to be over here. We have to be everything bigger than 5/3. So anything that's less than 5/3, so anything to the left of this value, is also going to be D and E. So 3 out of the 5 intervals are gone, which thankfully that helps a lot. Okay, so over here, now we want to test some values. So between -5 plus root 77 divided by 2 and 2, the -5 plus 77 is about 1.8-ish, which that does not leave a lot of room. I'm going to test 1.9. I'm going to get pretty close to that too. And then to the right of the 2, I'm going to test 3. So thankfully, these are the only 2 values I got to test. Okay, so what I want to do is I want to find where the values are negative. So if I do f of 1.9, so I would plug in 1.9 for all of these, for all my x values, and I want to see if it's going to give me a positive or a negative value. So when I plug in, tragically, it does give me a negative. All right, and then I just realized I messed up on my key. Whoops, but it's okay because I caught it. So now what's going to happen is I'm looking for the test value of 3. So I'm going to do f of 3, which this one I can do by hand. So this would be 3 squared, which is 9, plus 15 minus 13. So this would be 9 plus 2, which is going to be log of 11, log base 2 of 11. And then over here, I'm plugging in 3, my goldfish brain, I keep forgetting. So this would be 9 minus 5, which is going to be minus log base 2 of 4, which that would give me a positive value. Okay, so when I look at my inequality up here, I want where it's negative. So the interval that I want is going to be strictly where it's negative, so I specifically want this interval right here. So this is going to be from -5 plus square root of 77 divided by 2 to 2. All right, I will say, if you want to do these problems, you can. These are really just going to be renditions of what I just did. But if you want to do them on your own, I will tell you the answers for these are going to be 7 plus the square root of 401 divided by 16. That's going to be with a parenthesis. So we can be equal to it. So then this is going to go until 5/2, and that will have a bracket. And then for this last one down here, so let f of x equals all that garbage and g of x equal that garbage. Find all possible values where f of x is less than g of x. So this one is just 4 to infinity. Ta-da! So I would say, because of the values on 37, I would say yes, you can use a calculator. But 38, you should be able to do this one no calculator entirely. So this would also be a good one. So have fun.